And that was a great little energy refresher, right? Because I think that some people are probably a little bit tired now after the whole day, you know? Your whole head is filled with new knowledge. But we have one last talk, and I think it's going to be a really good one. And this presenter, he is an iOS developer at Wire. And he's also been regularly contributing to open source. In fact, I first got to know him a few years back when he started contributing to some of my projects, which was really cool. And I wanted to give him an extra warm welcome because this is actually his very first talk he ever has done. So I think this is going to be really great. He's going to talk about your app's secret life in the background. When you push the home button, what goes on, right? What happens in the background? So give a very, very extra warm welcome to Mr. Alexis Aubry.
All right, hello everybody. My name is Alexis Aubry. I'm currently, as John said, an iOS engineer at Wire, a secure communication tool based in Berlin. So yeah, thank you all for being here so late today. I hope the coffee is helping you all stay awake. Front row, right? So yeah, jokes aside, today we're going to be having a look into the hidden life of our apps when we move them to the background. So why is it interesting? In short, delivering a good user experience means more than just delivering a good foreground experience. It's true that when building an app, a lot of focus and effort is put onto crafting the best foreground experience for our users. So for example, we all think in terms of flows, in terms of speed, delightful animations, 60 FPS scrolling, and so forth. However, our apps also have a secret life when we move them to the background. And the system watchdog is here to make sure everybody behaves. And this is usually why we hear about background issues through customer support, because our users complain about high battery consumption, missing notifications, or also slow sync when reopening the app. So here's our plan for today. Our goal will be to learn more on how to provide the best experience for our users, even when they don't interact with our apps. So at first, we will remind ourselves what it means to be in the background. Then we will try to identify what kind of problems or common pitfalls our apps can have. And finally, we will go through some techniques to improve this experience. And yeah, let's get started. So our first topic, what does it mean for an app to be in the background? So as a quick reminder, multitasking was added in iOS 4. Prior to this version, your app would be terminated every time you pushed the home button. So yeah, since then, we all know that the system grew to be more supportive of background execution. Apps can be in different states and not just the foreground. But it does come with some rules and limitations. There are a few major cases where your app can be running in the background. The first one is when the user minimizes your app. It can also run in the background when it is woken up by the system in response to a push notification. And this is also the case for scheduled or event-based background refresh. So yes, mainly two cases, transitioning to the background and responding to events that the system sends to your app while it's not in the foreground. So yeah, both have pretty different life cycles and a different set of rules, and it's important to keep them in mind. So that's why we'll start by having a look at what happens when your application moves to the background. So yeah, let's say that the user wants to go back to the home screen. They push the home button, flick, whatever you name it. What happens exactly? The first thing that the system does is calling the application will resign active method on your app delegate. It's there to let you know that you're about to move to the inactive state. At this point, your app is still running, but it might transition to the background soon. Here, it's usually a good thing to stop your timers or pause your game if your app is a game. And yeah, basically this method is like a change of speed limit on the road. You need to slow down and prepare to stop if needed. But important to remind is that this is not the only time that your app can receive this call. For example, system alerts, phone calls, or notification can also trigger this. So don't start tearing down your entire app yet. After this, the system calls the application did enter background method. At this point, your app has already transitioned to the background, and you need to react quickly, because your app can be suspended at any time from now on. And in fact, according to Apple, you have about 5 seconds to return from this method. If you don't, the system will terminate your app and it will be purged from memory, which means that the users will lose their current context and maybe even data, and they will need to start over when they reopen the app. Later in this presentation, we will see how we can extend this lifetime so that you can avoid your users ending up in this frustrating case. But what you really need to remember about app did enter background is that you need to release as many resources as possible in the shortest amount of time possible. So a good idea is tearing down memory-heavy objects that you can reconstruct later, remove KVO observers, for example, and save some app state that you can restore later in case your app gets terminated or gets woken up after suspension. Here we have a very short step that you don't have to do anything for. The system will take a snapshot of your current UI so that it can be displayed on the app switcher. And finally, your app is transitioned to the suspended state. At this point, it remains frozen in memory and it cannot run any code. The purpose of this is that when the user wants to come back to your app, it is completely ready to be defrosted and to run as close as they left off. And it's also easier for the system to resume your app from a frozen snapshot in the background and reopen it later than restarting it from scratch, because then it's going to use a lot less CPU resources. And that's why it's a good idea to not force quit all your apps on your app switcher. However, the system can decide to terminate your app at any point from now on. And without any warning, actually, if it's under memory pressure. For example, if the foreground app needs more memory. And this is why it's very important to do the proper tearing down and site preservation in app did enter background. All right, so we've identified what happens when your app moves to the background. But there's another case where you can be executing code with limited resources. And that's when your app responds to events, whether they are push notifications, location updates, or background fetch. So let's see what happens there. When the system wants to wake up your app from the background, the first thing it does is checking whether it's suspended or not. If your app is not suspended and the system does not have any representation in memory, the first thing that it's going to do is calling the usual flows, like main, UI application main, app did finish launching with options, etc., to bring your app back. Otherwise, if there is a snapshot in memory, it will just reopen the app from memory. After this sequence, optionally, you get a call to app did enter background. And there you should try to avoid tearing down anything that you will need to handle the event. Then the event is distributed to you in the appropriate callbacks. For example, there's on the application delegate handle events for background URL session, or did receive remote notification, and so forth. At this point, you also need to process the events very quickly. The exact time that you have depends on a lot of factors. And because you won't get another call to app did enter background, after the event handling is done, you also need to make sure that you tear down everything that you use to process that event after you're done. Otherwise, the system might decide to terminate your app, which can lead to missing notifications or data, for example. Then again, you have the UI snapshot, and you are back to the suspended state, and this is the exact case as minimizing the app. The difference with the previous flow is that it's all performed in the background, even the launch sequence. That means that any task that you perform must be developed with speed and cleanup in mind. So now we know the flows of background execution and some of the issues that might arise. And speaking of these issues, we'll now see how we can identify that you have them. The first thing that might alert you about background issues in your app is the app crash logs that you can get from Apple or your preferred crash reporting service. There are specific termination codes that you should all keep in mind if you do anything in the background. The first one is actually a clever pun. It's ate bad food. This is reported when the system watchdog detects that you are taking too long to respond to a system event or that you are blocking the main thread for too long. But we'll talk about this more in detail and how to avoid this in a few minutes. Then we have deadlock. If you hold on to a locked file when you are being transitioned to the background, you will have a crash with this code. For example, it can happen if you are using core data and you do not relinquish access to the store file. Now comes, that's hard to say, C51-01. When the CPU usage in the background is too high, the system can decide to terminate your app, and it will let you know with this code in the crash logs. If you have this, you usually need to investigate your code and see what routines use the most resources. And they also have a little sibling, bad02. When you take too much time to complete a background task or finish the transition to the background with appdid enter background, you will see this number in the crash reports. At this point, same, you should also have a look at what takes the most time to complete. And the latest one in the family, bad03. Usually, with this code, the app was not terminated because you did something wrong, but rather because the system was under a lot of pressure. And this is a normal part of the app lifecycle. And if you have this, it's usually not worth spending too much time investigating. And finally, bad A5E47. This one is reported when you hit the limit of possible background tasks. We will have a look at a possible solution for this case a bit later in the presentation. Besides crashes, there are other symptoms that might help you identify that you have issues with your background handling code. Another big warning sign is when your users start complaining about missing push notifications or slow syncing when reopening the app. For example, if you are scheduling local notification in response to a background fetch, and that you cannot fetch the data in time, you might not be able to present that push notification. And if this is something that frequently happens to your users, it might be worth looking into these background issues and check your crash logs to see if you get one of these little codes that we just saw. And one last thing to check when you are debugging background issues is how long your app spent in the background compared to one of your competitors, for example. So this is useful because sometimes you might be spending a lot of time in the background processing some data, but just always take under the system limit. For example, if you spend 20 seconds for every push notification, you will most likely be fine because this is technically under the limit, and the system will not terminate your process. But however, this 20 seconds add up, and that might be detrimental to the user's battery life. So following these practices at Wire and fixing our code for background, we were able to shave off more than 5 hours of background time over a week of work messages, which was, of course, a big win for battery life. So now that we identified that we're having issues in the background and that it's affecting our users, what can we do about it? And how can we adopt the techniques for the best background experience? The first essential thing to do is using the background tasks API. As I mentioned before, you only get 5 seconds to tear down your app once it has started moving to the background. However, if you need more time to complete a task, you can use the begin background task method of UI application to tell the watchdog that you are beginning a task that requires more execution time than usual. So this is how the system works. You have your code and you have UI application. First, you start by calling the UI application method to tell the system that you want to start a task with extended lifetime. At this point, the watchdog will allow you to perform more work while being in the background and waiting to be suspended. This method takes a parameter, the expiration block. This block will be called when the extended lifetime permission is about to expire. So basically, it's called when your app is about to be suspended. Here, it's very important to return as quickly as possible and clean up as many things as possible related to the task that you are performing, because your app is about to be suspended. And if you don't return in time, it might cause a crash. And there's another very important thing about background tasks. You always need to specify the application when the associated work is finished. It's not enough to just return from the expiration handler in time. To tell the system when the task is over, you need to save the task ID that beginning background task is going to return to you, and save it somewhere that your work-related code can access. And before doing anything, you also need to check whether the task ID that you get is equal to the invalid ID. It means that if you get this, it means that you don't have enough time to start a background task because you are already really close to the expiration limit. And in this case, you really need to not schedule anything and return from the current scope as quickly as possible, because you're already about to be suspended. Another important thing is to perform the work that you are about to do on another queue. Never perform long-standing tasks on the main thread, because this will completely defeat the purpose of the long time allowance, because you will still have about 5 seconds to return from update to background. And when you are done with the background work, as I just mentioned, you need to notify the system by passing the task ID that you got from begin task to the end task method. And you can do it when your task completes, for example, in the callback of your network request, if that's what you are doing, for example. And it is also imperative that you call the end background task in the expiration handler. If you don't, your app will inevitably be terminated by the system. And also note that the expiration handler will not be called if you end the background task before it expires, so do not rely on the handler to clean up things. And I have a very quick word about app extensions. Because UI application is not available in extensions, if you want to use background tasks, in this case, there is a method on the process info class that lets you do that. You call the perform expiring activity method, pass it a reason string that describes the task, and a block. The block is what we call reentrant. That means that it takes a bool parameter and it will be called 2 times. The first time, it's going to be called with the parameter set to false. It means that you can perform your work. And the second time, it will be called with a parameter set to true, which means that you should act as the expiration handler and clean up and cancel everything. Yeah. So now the question is, in what scenarios do you need to use these background tasks? According to Apple, you need to wrap your work in a background task every time that interrupting it will be detrimental to the user experience when they reopen the app. So for example, if you are making a network request to send a message or to save a local file, you should wrap it in the background task so that you get extra time to finish it and make sure that the user does not lose anything. An even better practice is to actually use background tasks when you are operating in the foreground. For example, if you start sending a message and the user closes the app immediately after they hit the send button, you will start making the request, but then you can end up in this weird state where the background flow is starting, but your network and processing code doesn't know, so everything might fall through and the message will not be sent. The caveat is that you can also have a termination if you exceed the maximum number of allowed background tasks. So be careful with how many tasks you start. For example, starting a task for every networking call can quickly cause issues, and I speak from experience. There are also a few steps that you can take to make the most out of background tasks. The first one is to give a name to your background tasks when you create them. It makes them easier to debug because this name will show up in the crash reports. Something else to keep in mind is that while the API says that it can be called from any thread, it's actually better to schedule all these tasks from the same thread. It doesn't have to be the main thread, but it should always be the same thread. The reason behind this is that the actual underlying implementation of background tasks runs on an asynchronous system service, and that might all get out of sync when you start scheduling tasks from all over the place. And finally, the next step is a bit more involved, but it can really be beneficial if you decide to incorporate every long-standing work in a background task, as we discussed just now. And this can also help you avoid crashes related to having too many background tasks. The idea is that you can write a central manager for scheduling and completing background tasks. So let's see the benefits of such a construct. So the goal, as we just said, is to have a class that manages a single background task and mimics the API of UI application to keep your app awake. This can have huge benefits because it avoids the overhead of creating multiple tasks, such as interfacing with the system daemons every time that you want to end or start a task. Another nice thing is that if you need to perform multiple units of work that depend on each other, it means they can all use a single task that you create at the beginning, and you don't need to worry about having a few seconds of gap between each work item, which can be a problem because the system might think that that the app is not doing anything, and therefore that can be terminated, even though that's not the case. And finally, another benefit is that it solves the issue of having too many background tasks, and it solves the issue of creating them for multiple threads. So yeah, let's see how we can build this now. This is an overview of how it would work. We have 3 actors, your code, the background task manager, and UIKit. So you start by calling begin background task on your manager with the code that you want to run and the expiration handler that you should use. If it doesn't have an internal real background task, the manager will ask the UI application to start one. It's going to save it and register its own expiration handler that's completely opaque to your code. If the manager already has an internal task, or after we create it with UIKit like we saw just now, the manager will store the expiration handler from your code and return a token for you to cancel the task. When your code is finished, it notifies the manager by calling end background task and passing the token. If after calling this method there are no more active tasks in the manager, we can safely tell UIKit that we are done with all the work and that it should end the internal real task. And when UIKit notifies us that the app extended lifetime is about to expire, so that we're going to be suspended, we call all the expiration handlers that we saved in the manager, and then we tell UIKit that we tore down the app and that it can safely stop. And also a nice thing that you can implement is if you try to start a task and you get an invalid ID from UIKit, you can block the code from running and tell it to execute the expiration handler immediately, and this is going to avoid crashing after the app expired with the 8-food code. I have published an example implementation on GitHub if you are interested in checking it out after the presentation. So the next big thing that you can do to improve the background experience is being mindful of the memory usage of your app. Of course, this will be super beneficial for your users when they're in the foreground, but this is also going to be really helpful with the limits of background execution. In fact, reducing your memory usage will make the system more likely to keep your app suspended for a longer period of time when it needs to make room for a foreground app, because then your app doesn't use so much space and it can stay there. And for example, you can make sure that you use the proper caching for the data that you generate in the foreground. And you can use the disk to process some of it if this is appropriate. You can also reduce your use of images and other assets to keep your memory footprint as lean as possible. Many documents exist on the topic. If you want to read more about it, there are 2 good articles by Apple and Thomas Henning that I can recommend reading. And yeah, we'll publish the slides after so that if you want to go back to these links. Another thing to check is whether you are using the right API for the right task. For example, if you process notifications in the background, you should make sure to use a notification service extension, which allows you to process the notification without waking up your entire app. It's going to use less resources, you can focus on your work, bam, you're done, and you don't need to take care about tearing down your entire app. This is going to be much more efficient. And if you are downloading or uploading big files, you should use a background URL session with session sends launch events set to true, so that the session will wake up your app when the transfers are done or failed. I would really recommend reading the guide from Apple about this if background transfers is something that you are doing. And last but not least, I want to have a word about how we can improve our architecture decisions and our discussions to take background execution into account. As Apple says, apps must be prepared to be terminated at any time. This means that you shouldn't wait for the app to be sent to the background to save the user data. In addition to this, there are some steps that you can take when designing features to make them more friendly with the background execution. A good first step to take is to make every task cancelable. This is going to allow you to clean up everything more easily once you need to handle the expiration or the suspension. But going beyond the compliance with the system limitations, you should also take the user experience into account. For example, if you cancel a network call to send a message, how do you let the user know? For example, a solution to that would be trying to schedule a local notification to prompt them to open the app and resend the message. Otherwise, they will never know that their recipient never received the message. And this is definitely something that you should bring up next time that you discuss the implementation of something new. So what should happen if we have to cancel the task in the middle? Is this task recoverable? And do we need user interaction to recover from this problem? On this note, we are done for today. So we're going to have a quick recap of all the things that we went through. There are multiple scenarios where your app will have to run in the background, and they each have different rules. You need to comply to these rules, and you need to make the most efficient cleanup when you are prompted to, so that your app can stay frozen in the background as long as possible. There are some signs that can warn you about issues in the background, such as specific crash codes and user complaints about missing data and high battery usage. You should use background tasks as often as possible, but at the same time, you should be careful about its caveats, and it's a nice idea to try to define a central place to manage them. It's a good thing to use the latest system APIs and the newest extensions to optimize your background work. System-specific extensions are also your friend, like the content extension. And finally, it's good to design for immediately cancelable tasks and restoration, and you should all think about the user experience. All right, thanks everyone for your attention. I hope this was useful and that it will all help you with some problems that you've been fighting with or going forward when you implement new features. So if you have any questions, you can come at me or tweet at me. I'm @_Alex Aubry on Twitter. So thank you.